So the first example, we're going to find I/O in the network using linearity, and the assumption I/O is equal to 1 milliamp. So I/O is the current over here. Now we're going to use linearity to find I/O. So the first step, we're going to assume I/O, which is given. By assuming that, we'll be able to solve for the source, solve for Vs prime. So since we assume the I/O, so this is not the actual I/O, so let's call it a I/O prime. This is the current I/O prime, and we're going to find a Vs prime. Vs prime is the voltage here in replace of the voltage source. Let's see how we do that. If we know the I/O prime over here, we'll be able to find the current in this branch, in the 2 ohm resistor. So let's call that I1. Give it the name I1 prime then, so that we know that all the labels or all the variables with prime is based on assumption, it's not the actual current. So this is my current I1 prime. So what is I1 prime? Since the resistance is 1/3 of that, so it means the current is 3 times of that, right? So that is 3 times I/O prime, which is equal to 3 milliamp. And with these two currents known, we will be able to find the current in this branch. The current in that branch, let's call it I2 prime. I2 prime is equal to the summation of the other two currents, I/O prime plus I1 prime. So that is equal to 4 milliamp. Keeping I2 prime, we will be able to find the current in this branch, the voltage drop on this right-hand side, divided by the resistance that will give us I3 prime. I3 prime will be equal to 3 times I2 prime, that is the voltage drop on this 3K, so 3 times I2 prime, plus the voltage drop on this 2K resistor, that is 2 times I1 prime. So that is the voltage between these two nodes, divided by 6, that will give us I3 prime. 12 plus 6, 18 divided by 6, that is 3 milliamp. So we find I3, and if we find I3, we will be able to find the current in there. So the current I4, let's call this current I4. The current I4 prime is equal to I3 prime plus I2 prime. I2, I3, so that is a 7 milliamp. After we find I4 prime, we'll be able to find the source Vs prime. Vs prime will be equal to 2 times I4 prime plus the voltage drop from this node to that node. So this will be 6 times I3 prime. So this is 14 plus 18, so that is 32 volts. So step 3, we'll be able to use the linearity, or you can be more specific, say use homogeneity to solve for I/O. And the linearity relationship tells us that the output of I/O over the input, which is the voltage source Vs, this should be equal to the same relationship with assumed values, so I/O prime over Vs prime. So from here we can find I/O. So that will be equal to, this is 32, and the actual, that is 64, which is 2 times of that, so it means the actual output should be 2 times of the value that we assumed. So that is 2 milliamp. So this is how we solve the problem. Next question, we're going to find I/O in the network using superposition. So look at the problem. How many supplies do we have? 1, 2. We have 2 power supplies, and we're going to use the superposition to find I/O. So I/O is due to the 2 input. One is a 6 volt voltage source, and the other one is a 2 milliamp current source. To find the output for that, we can decompose this into 2 problems. And the first part, we'll call this I/O prime. For the second part of the circuit, the contribution from the current source, we need to set the other one to be 0. And how do we set the voltage source to be 0?
Replace with wire.
With a wire. So we also mentioned that the common mistakes students make was like that, just like throw that away. Then that's a mistake, don't do that. So we will replace that with a wire. So put a wire here. So the first circuit will result in an output, we'll call it a I/O prime, and the second output due to the second power source, which is called IO double prime. So now one problem is decomposed into two smaller problems, so we just need to solve them one by one. So how do we find IO in this problem? We only have two branches in parallel and with another resistor there. So to find this current IO prime, probably we can find the overall current first. So let's find the overall current. Let's assume the overall current is call it I. And the overall current can be found by using Ohm's law, using the total resistance applied on the network divided by the resistance. So I is equal to 6 volts over the total resistance, which is 6 plus 2 in parallel with 3 plus 3, because these two 3 in series. This is 1.5 plus 6, 7.5. 6 over 7.5, that is 12 over 15. We can also simplify that as 0.8. So after we get this overall current, we'll be able to find the current IO prime. So IO prime is equal to part of the I, the total current I. The numerator is the resistance of 3 plus 3, and the denominator, which is the summation of these 3. So it is 2 plus 3 plus 3. So we find IO prime is equal to 0.6 milliamp. So this is how we solve the first part of the circuit. For the second part of the circuit, we have a current source over here. We are looking for the current through one branch over here. So to find the IO double prime, I want to know the current over here before I can split it into two branches, right? So that is something I'm going to do. I want to find the current over here. But to find the current over here, if we look at the left-hand side and the right-hand side, that will become a current division circuit, right? So the same thing, we're going to use the same conclusion twice. Sorry, I forgot to label this current. So let's do that for the second part of the circuit. I want to know the current through here, call it I1 then. So we can find I1, the current in this branch should be equal to something divided by something times the overall current, which is a 2 milliamp, right? So that is something we're going to do. On the numerator, which is the resistance in the other branch, which is 3K, and on the denominator, which is the summation of the resistance in the two branches. The resistance in this branch, that is 3, the resistance in the other branch, which is a 3 in series with 2 and 6 in parallel. So this is the resistance in this branch, this is the resistance in the other branch. When I said the branch means like the whole thing on the left hand side. So this is how we find the current I1, 6 over 7.5, 0.8. So IO double prime, we're going to use the same conclusion again. The current in this one branch should be equal to a share of the total current. The only difference is now the total current become I1. So the total current in here that will split into two branches, the current in one branch is equal to the part of this I1. The numerator is the resistance in the other branch, which is a 6. And the denominator, which is the summation of the resistance in these two branches, which is 6 plus 2. So we get 0.6 milliamp. So now we find the two. So I forgot to label them like step 1, step 2. So let's call it, this is step 1, we solve the first part of the circuit. And step 2, we solve the second part of the circuit. And then step 3, we'll combine them together. So combine the two parts by using superposition. We know that the overall output I/O should be equal to the summation of the two. So I/O is equal to I/O prime plus I/O double prime. So in that case, it's 1.2 milliamp. All right, let's look at the next problem. It's a little bit more complex, but it's the same thing. We're going to use a superposition to find a current I/O. But the problem just looks more complex compared to the previous one. In this problem, we have 3 power sources. It means that we're going to decompose this problem to 3 smaller problems. In the first part, we focus on the voltage source, 12 volts. We will set all the other to be 0. And we'll set the current source to be 0. So that will be gone. And the other current source to be 0. And this will be gone. So that will become our new circuit. And in the second case, if we focus on this current source, we will set this to be 0, so this will be gone. And at the same time, so we'll make this voltage source to be 0. How do we set it to be 0? We'll replace it with a wire. Always remember that. We need to replace it with a wire. And in the circuit, we focus on the current source of 4 milliamp. We will make all the others to be 0. This is the way how we make it a 0. And the way we make the voltage source to be 0 is like this. We'll replace that by a wire. Alright, now we have the 3 circuit problem to solve. Let's solve them one by one. Step 1, I'm going to solve this one. This is the first part. So we're going to find this current, give it a name, say IO prime. And cover all these IOs. And the first current is IO prime. So how do we find IO prime? So by looking at this problem, so this part doesn't matter because this part is not connected in the circuit anymore, right? So we don't need to worry about the 12 kilo ohm. So we only need to look at this. So right now we have 12 volts applied between these two nodes. So the current IO, to pay attention to the sign, because it's not following the passive sign convention. The positive on the top, and the negative is on the bottom. So which tells us that IO prime is equal to negative 12 divided by the two resistors in series, 6 plus 6. So that it will give us a negative 1 milliamp. So that is how we solve the first part. The second part we're going to do it here. So this is the second part of the circuit. In the second part of the circuit, there's a current source over here. We are looking for the current IO double prime. So IO double prime is over here. How do we solve for IO double prime? IO double prime is the current going there, and we have a current source. And what is the IO double prime? So let's look at the circuit. What happened to these two resistors? Are they connected to the same node?
Yes.
They're connected to the same node. It means that there is one node here, it stick out with one resistor, in series with another resistor, then connected back to the same node. And this is shorted, right? So if it's shorted, there won't be any current going through this branch, because all the current will go through the wire. The wire has no resistance. If the wire has no resistance, it will go through the wire, it won't bother to come through the resistors, right? So if we look at the circuit over here, the current will flow through these two resistors, and then there's a wire. The current will flow through the wire, then through this 12K, then back. There's no current that will go through this branch. So that is something I want you to pay attention. So by looking at the problem, pay attention to that. In this part, these two resistors are shorted. So that is how we get a IO double prime is equal to 0. The third step, so we're going to look at the third part of the circuit. And what happened to these two 6K resistors? Shorted, right? You don't need to worry about these two. Over here, let's call that current IO triple prime.
What does the circuit look like if you were to redraw it? Just the whole left side would be gone?
Yeah. If I draw the equivalent circuit, so it will be like one source over here. There's two branches in parallel, then go through this 12K. And this over here is shorted. So it doesn't do anything in this circuit. It's the same rationale compared to what we have here.
Okay.
But pay attention, this IO triple prime means the current over here, and it goes from the left to the right. So we know that these two branches are in parallel, and at the same time they are of the same value. We know the current IO triple prime is half of the overall current. So IO triple prime that is equal to negative 2 milliamp. So it's half of that, but it's in the reverse direction. So we get it a negative 2 milliamp. So in the exam, if you write all these three like that, and you already get like 9 out of 10. And the last step is to get the conclusion of a current IO. So if we combine them together, and we can find IO is equal to the summation of all these three currents. IO is equal to IO prime plus IO double prime plus IO triple prime. Then we get the final answer is a negative 3 milliamp. Now we complete all the examples.